In this video, I'll be walking you through my pipeline to fine-tune a Llama 3.18 billion parameters model and show how I debug it using Doctor Droid playbooks. Open source AI models like Llama 3.1 are now performing at par with proprietary models, but they do have challenges with latency and require optimizations. When it comes to latency, Llama 3.18B is relatively the best, but can take tens of seconds for inference. Quantization has been found quite effective in terms of improving the inference speed. The 4-bit quantized version can infer in 2 to 3 seconds. This comes at the expense of accuracy, but the latter can be enhanced with fine-tuning. In any case, most production use cases are domain-oriented and model accuracy is relatively low. While retrieval augmented generation, RAG, certainly helps in using domain data with LLMs, using a fine-tuned model can be more effective in terms of quality, cost, and latency, depending on the use case and associated token usage. I now present the different stages of the fine-tuning pipeline for 4-bit quantized Llama 3.18B. The model is fine-tuned on documents associated with medical research. Attributes related to research papers were extracted using 8-bit quantized Llama 8.1-B and stored in a database. A fine-tuning dataset was created using this. A 4-bit quantized model of Llama 3.18B was then fine-tuned using Unsloth using this Colab notebook. While testing the model, samples were chosen from the fine-tuning dataset, and the model outputs were evaluated against the desired outputs. I had to debug a couple of things repeatedly when the model output was different from the desired output. Whether the difference was due to the randomness in the model or due to issues with the data loading in the pipeline. What were the reasons behind pipeline failure? Whether it was due to database connectivity, GPU memory constraints, or something else. Were there any issues with how data was getting processed in the pipeline or with the variables? The initial approach was to manually check the entries in the database for the corresponding record by referring to all the associated tables and then investigate the server logs and ETL scripts to debug the reasons behind pipeline failure. For every incorrect response, I had to refer to the tables involved in the query for generating the fine-tuning dataset and come up with queries to explore the discrepancies. This involved connecting to the respective database server frequently and writing queries to do integrity sanity checks on the columns that were returned as outputs. Further, when sanity issues were observed, the initial point of failure had to be located by tracking back the steps in the pipeline and checking the values of attributes at different stages. While doing this, I had to keep different tabs open, and it was a great pain navigating between them. Similarly, I had to connect to the database and job servers through PuTTY frequently and explore any logs, run a bunch of commands from my notepad that would help me locate any connectivity, memory, or space issues. It was time-consuming to locate the logs/details for the respective date and time. I was exploring a solution where I could codify the different scenarios and then just access the desired results when needed instead of having to connect to servers and databases every now and then and manually run the queries and commands. I came across Doctor Droid playbooks via some of their interesting content on LinkedIn. Playbooks is an open source framework to codify and automate investigations. It automates execution of queries and commands for fetching all relevant information to an incident from all relevant sources, thus avoiding the need for an engineer to connect to different environments and debug from scratch. By allowing engineers to invoke the playbook workflows based on conditions specified by them, Dr. Droid makes the results of investigation available to developers in case of any incident. I created a handful of playbooks for different scenarios like data integrity and sanity checks, and commands I need to run to debug any GPU memory space constraints on the servers. Also, since I had been facing issues with GPU memory utilization, I investigated the best practices for efficient handling of batch and real-time requests and efficient utilization of all available GPUs, and documented them through playbooks for the respective use cases. for enabling a quick reference when incidents occur. I also created the workflows for invoking the respective playbooks through the API trigger option provided therein. Finally, I updated my fine-tuned model validation code to invoke the workflows whenever the model output is found different from the desired output. On testing the fine-tuned model, if the model response comes out to be different from the desired response, the specified workflows are triggered, and I get the desired information for debugging on my Slack channel. For example, in the following case, even though the fine-tuning dataset had correct values, the model seems to have got misguided by missing authors of other papers, as there are a good number of data points of that kind. It was observed that a lot of incorrect responses generated by the model were due to mistakes in records loaded in the database. The GPU metrics were indicative of a balanced GPU utilization, and the root cause lay in Llama 3.1-8B based agentic workflow that was leading to incorrect extraction of attributes from the research papers. Having fixed the issues and incorporated the best practices in my code, I created another dataset for fine-tuning, fine-tuned the 4-bit quantized Llama 8.18B afresh, and reran quality checks. Since accuracy was found to be reasonable for production usage, I deployed the model in production. However, I wanted to make sure that I am able to debug all issues with the deployed model going forward. Therefore, I created another workflow for post-deployment monitoring by utilizing the cron scheduler option provided. Even since the model has been in production, this has ensured availability of metrics on a regular basis so far. This will ensure quick debugging in case of any incident going forward. If you are interested in faster debugging for your use case and are looking to use playbooks for the same, kindly refer to the tutorials on Dr. Droid YouTube.